Welcome back. In the last video, we practiced finding some altitudes using Trig, applying our Trig products to finding different things than different unexpected places in different triangles that aren't necessarily right triangles or even triangles at all, okay? Sometimes we can find right triangles in the most unexpected places, okay? Let's see this next section. We're going to look at the area of a triangle, which means I need to review the formula for area of a triangle. There's two different ways to write it. I generally will go with area equals 1/2 the base times the height. But you can also do base times height and then put all of that over 2. Dividing by 2 is the same as multiplying by half. Okay? So if I want to find the area of this triangle here, that means I need to know 1/2 the base times the height. The base in this triangle is pretty simple because I can see they gave me the bottom of this triangle as being 48. So I already know my base here is 48 units long. Okay, so that is my base. But I need to find the height of this triangle. Okay, so I need to find this piece here. So that is going to be my first course of action, is to figure out, well, how tall is this triangle? What is the height? I don't know. Okay, when you draw in the height, you know it hits the opposite side at a 90-degree angle, which means I make 2 right triangles, one on the right, one on the left. Look at this one on the right. I know one of the acute angles is 23. I know one of the sides is 32, and I'm trying to find the other side. So if I come over here and I look at just that triangle, where I've got a 23 and a 32, and my height that I'm trying to find, I can use Trig to find that height. So let's look at how we will do that. Okay, so the first thing I'm going to do is say, that's my right angle. This is my acute angle, so this is where I'm standing. My hypotenuse is across from the right angle. Okay, and then out of my smiley face is the hypotenuse that I already labeled, and the other side is the adjacent side. And then all the way across over here is the opposite side. Okay, so then I'm going to circle the 2 sides that I'm working with. I want to find that opposite side, and I know my hypotenuse is 32. So, ka, toa. All right, so let's see. My opposite side, even though it says an H, don't get that confused with hypotenuse, right? That's H for height, not H for hypotenuse. So you have to be, again, real careful, because remember up here, we had A for altitude and A for adjacent. So you really have to be careful on these, on your letters, and remember what they're standing for. This, even though there's an H, that's my opposite side. And then here is the actual hypotenuse, which is 32. So I can see I'm going to be using sine. So I'm going to come over here and do sine of the angle. Now I know my angle, so I'm not doing inverse. I'm going to put that angle there, 23, equals opposite over hypotenuse. My opposite is H. My hypotenuse is not the H. My hypotenuse is 32. And then I'm going to cross multiply. So I'm going to put this side over 1, and I'm going to do H times 1, which is just H, equals 32 times the sine of 23. So let's find out what our height is. My height is 32 times the sine of 23. And remember, in the last video, we had already moved my calculator into degrees. Okay, if I hit mode, you can see it is in degrees. Okay, I'm going to hit enter, and I'm going to get my height as 12.503. So that is this height right here. I know now that that is 12.503. Okay, because I showed that right here, which means now I can find my area. The area is 1/2 the base times the height. My base, we said, was 48. My height is 12.503. Move my mouse over a little. I'm running out of room. 12.503. 12.503. 3 for my height. So my area equals 1/2, 1 divided by 2, times 48, close my parentheses, open my parentheses, times 12.503. Close my parentheses, and the area equals 300.072. And since I have feet and feet, and feet, everything's feet in this problem, area is always written as feet or whatever your units are and then squared, because I'm doing 48 feet times 12.503 feet. So feet times feet gives me feet squared. That squared just describes the units. It has nothing to do with this actual number as far as changing that number. So my answer is 300.072. Okay. All right, let's look at the next little section here before we move on. The next is some new vocabulary, and we talked about it a little bit on Friday. We said that a regular polygon is a polygon with all sides congruent. So that means all 3 of these sides are the same. All 4 of these sides are the same. All 5 of these sides are the same. All 6 of these sides are the same. And all my angles are also congruent, which we've already talked about. If I have an equilateral triangle, we know they're all 60 degrees. In a quadrilateral, they're all going to be 90 degrees, and then we'll call it a square. And then next week, in the next unit, we'll talk about how to find all of these equal angles in a regular pentagon and all 6 of these equal angles in a regular hexagon. Okay, so we'll talk about how to find those measures in the next unit. Okay, but a little more vocabulary. The center of a regular polygon is the point that would be the center of a circle drawn around the, that shouldn't say circle, around the polygon. Okay, so if I were to take and draw a circle around this triangle, I would find the center of my regular polygon. Same thing here, I would find the center of this square, the center of this pentagon, and the center of this hexagon. Okay, the apothem, remember, is the distance from the center perpendicular to the side, and it divides it equally in half. So if I look, my apothem would go straight and it would hit the opposite side at a 90-degree angle, and it would divide this opposite side into 2 equal pieces. Same thing here, it would hit at a 90-degree angle and divide this into 2 equal pieces. That would be true for all of my shapes. Divide the side into 2 equal pieces, hit at a 90, and divide into 2 equal pieces. That is my apothem. Okay, and then the last new word is not really a new word to us, but it's new. We've never seen it in a shape that wasn't a circle before. The last one is the radius of a polygon, and that's the distance from the center point to a vertex. And notice what's kind of neat is when you draw the distance from the center point to a vertex, it's also the radius of that circle that would go around the edge, right? From here to a corner, from here to a corner, from here to a corner is going to be also the distance to that circle around the figure. Okay, so if I look at this figure that I have down here, this pentagon, and I say point A is we know that is the center of that figure. Segment RA, from R to A, that is a radius of that polygon. And segment AP is the apothem of that figure. So you need to make sure that you can identify the center, the apothem, and the radius. And for my apothem, we'll always label that with a little lowercase a. And I know we've already got altitudes and we've got adjacent sides, but little lowercase a for apothem. and my radius will always be a little lowercase r. Okay, in the next video, we're going to look at finding the apothem. We're going to practice finding apothems of a couple of different regular polygons. Okay, so come on back for that. Thanks for watching.